We're going to work with this topology table quite a bit now, but one thing I do want to do is go back to the board, which is a little off kilter right now. Let's go back to the diagram. Bear with me here for just a moment. And I want to go back to one that we weren't blocking any interfaces or anything with. There we go. So right now, just recapping very quickly, we've got two routes from router 1 to router 2's loopback. We have two routes from router 1 to router 3's loopback. We saw the primary one in place, the successor, and we also saw that the metric of the feasible successor in each case is very, very close to the metric of the successor. Not quite equal, so we don't get the default equal cost load balancing, but what we are going to do is some unequal cost load balancing. Let's go ahead and bring the table back up, and again in the EIGRP topology table, we see that we have equal cost load balancing going on from router 1 to the Ethernet segment. That we've got in place. But look at these metrics for the route to router 2's loopback from router 1 and again to router 3's loopback. Those metrics, also known as the feasible distance, that's the first number you see in the paren. We're going to have another section on this later, but I just want to mention this now. That is your feasible distance. That's the actual metric from this router to the destination network. That's also the metric you're going to see in the routing table. The second number here is the advertised distance. It also has another name because this is networking. We like to have more than one name for the same thing. And I'll give you that name when we get to it. I just want to stick with feasible distance right now. That's the value we're concentrating on. Well, again, we've got two metrics here for the path to router 2's loopback. That's the one we're going to concentrate on first. And they're so close that I would look at that and say, if I had a sizable amount of traffic going to router 2's loopback, it's like, hey, why am I using one path here instead of two when they're almost as good as each other? That's the kind of thinking you want to have, and you're looking at this, and what we can do is enable unequal cost load balancing with the variance command. And one magic word enables unequal cost load balancing. I just gave it to you. It's variance. Typing the word, that's the easy part. It's the number that follows the word that you have to watch. Now, this is one of those things that in print, or even when someone reads it to you, the variance command, I have seen some horribly complex definitions of this over the years. All it is a multiplier. It has a default value of 1 that you can see in show IP protocols. And the router is going to multiply the feasible distance by the value we put in for variance. Any feasible successor with a metric less than that new value will go into the routing table. It's not actually going to change any metrics. That's a very important point with the variance command. It is not going to change metrics. It's going to make a metric more acceptable to the routing table. Now, as I say here, that sounds a little bit confusing, perhaps even a tad askew. So what we're going to do is see it in action here with router 2's loopback, with the route to router 2's loopback, I should say. And right now, we've got a metric of 229.7856. I'll bring it up on the real equipment. 229.7856 for the primary path to successor. We have one of 230.0416 for the feasible successor. So a variance of 2, this is what's going to happen. Any route then to 2220 that has a feasible distance of less than 229.7856 times 2 is going to go into your routing table. Well, 230.0416 certainly qualifies for that. So let's go ahead and look at our options for the variance command. And you'll be happy to know, frankly, they're few and far between. This is it. And you can see you cannot set it to 0. Now, when you set it to 1, which is the default value, that means you have equal cost load balancing enabled. So as we can see here, you really can't disable equal cost load balancing in EIGRP. So we'll go ahead and put our 2 there that we came up with. And we have absolutely no other options for this command. We'll take that. So we've got variance 2, and we put it in, and we get a little timestamp, and that's it. So what's going on here? We didn't get any messages as far as resyncing any adjacencies, anything like that at all. Let's go ahead and check our tables. And look at this. Now, in the past, you had to clear your routing table to make variance take effect. I've seen that with a couple of different iOS versions. So if you run into that in the real world, you might have to clear your routing table, because using this command is not really considered a change to the network. It's not going to trigger updates, but here it's already worked for us beautifully, and we love that. We'll take it anytime we can get it. And note again that the metric of the feasible successor did not change. That's a very important point, and I know I've said that twice, and there's a reason. Because people do tend to think, well, it changes some route metrics. No, it does not. What it does, it makes a slightly higher metric more acceptable to the routing table. So while the metrics didn't change, we do have load balancing going on to router 2's loopback. And you can see there's our network, there's the administrative distance of 90, which we expect, there's our metric, our feasible distance, you see the next top IP addresses, how long it's been in the table, and the exit interface. Now, you'll note also that we have 2 entries for router 3's loopback. We didn't discuss that. We didn't even look at the metrics of it. This is why you got to be careful with the variance command, because variance is all or nothing. You can't set, as you could see with iOS help, we didn't have any options. we had router EIGRP P100, variance 2, that's it. We couldn't say variance 2 and then a route name or a route number, anything like that. So you have to be a little careful with this command, because what you can do is you can end up with the load balancing you want while also getting perhaps some load balancing that you don't want. Now let me show you show IP protocols. We'll look at that. I know you're very familiar with this command, but you can see under EIGRP 100 that maximum metric variance 2, that's what we set it to. And we see our distances here, internal 90, external 170. Ignore the maximum hop count of 100. That's still in there. I'm a little surprised, but it's still there. It's not a value we're concerned with. We are a little concerned with that maximum path 4, though. And let me show you a little something here might surprise you. Let's go into router EIGRP 100. Number of paths 1 through 32. Now the default is 4. And you can expect to see that in every iOS. But what I do want to point out to you, and what might be surprising to some of you, is you've seen this command in other videos that I've made with earlier iOSs, and you say, wait a minute, I thought that was 1 through 16. Or maybe you've seen 1 through 8. It does differ. There is no absolute universal maximum number of paths for this. It depends on the iOS you're using. That's not going to get, the CCNP route exam is not going to get into iOS versions. I do want to point out to you, though, not only can you have a different number of maximum paths from one router to another, but you cannot set it to 0. And if you set it to 1, what are you doing? If you set that to 1, you are effectively disabling any kind of load balancing, equal or unequal, because you're saying, hey, I want 1 maximum path and that's it. So if you ever wanted to disable equal cost load sharing, you could actually set that to 1. Very rare that you're going to actually want to do that. Now, I want to go back to variance for a moment here, because I know at least one of you was thinking of this, because I know I was thinking of it back in the day when I was studying for my CCNA. You bump into the variance command, and anyone who knows me has ever taken a course, you know that I'm not scared of math. But, you are thinking, well, wait a minute, why do I have to figure out any route metrics or anything like that? Why do I even have to look at it? I'll just put variance 255 in there, or variance 128, which I believe was the maximum here. Now, let's take a look at that. Yep, let's just say you went variance 128. I'll just put variance 128 there. No problem at all. Well, the problem is, as you've probably guessed from seeing the little change to router 3's loopback, is that you'll get the paths that you want, but you might get paths that you don't want. And let's say that you have 3 valid paths to the same network. EIGRP has determined that your 3 paths are valid, they're loop-free, no problems whatsoever. Path 1 has a metric of 5,000. Path 2 has a metric of 7,000. That's pretty close. And path 3 has a metric of 55,000. Now that gives us 2 links that are really close in speed, and a third path that is way slower than the others. When you've got one path that is 11 times as fast as the other, maybe you don't want load balancing there. It's a good backup link. We'll take all the redundancy we can get as always, but it's not one I would use in load balancing. You'd have to make up your own mind with that, but this is the reason you don't just type in variance 128 or variance 255 for a maximum depending on your iOS. You just don't do it. Also, I can practically guarantee you that actually I will guarantee you, if this comes up on your CCNP route exam, it's not going to let you just say, oh, just set variance to the maximum and it'll be fine. Don't do that. So it just takes a minute to do that math. It's some of the simplest math you'll ever do, and I know you can handle it. Coming up in the next video, we're going to talk about some dual queries. We've got some questions that need to be answered on occasion, and also what the heck a passive route is. You've already seen them. There's your teaser, but we'll talk about them and see them in action in the very next video.